Hello, Maths 126 fans. I want to do a little polar intro just so I can do a bit more details than I might do in class. I still will talk about these things, but I'll say a few things about some homework questions, so stay tuned here and I'll try to keep this short. So for this video, I'm just going to do the introduction to polar coordinates. Polar coordinates is a different way of thinking about how we navigate around a plane. Your whole life we've been doing it the way a taxi cab does it, meaning we've been giving directions that say go down this many blocks, go over this many blocks. At some point, hopefully that has become second nature, but there were a bunch of conventions. The conventions were things like we're going to call this direction positive x. Why? Because we're all going to agree to it. It doesn't have to be, but we do agree to it. We're going to call this direction positive y. We're going to call this the origin. When we go over 3, we go up 5 parallel to the y-axis. So you think about this, if you're explaining this to somebody, you have to explain several conventions. What's positive, what's negative, what we mean. We call that the Cartesian system. And that's a system you've used for a long time. That system is good if you're trying to describe things in terms of x or in terms of y. It's not so great if you're trying to describe things in terms of rotation, something that's spiraling. For that, I always say, if you want to take your homing equation out and say, go fly here, you don't say fly 3 blocks this way and 2 blocks over. You might point them in the right direction. Or if you're firing, a water balloon cannon or something, you can't say, all right, water balloon, I want you to go 3 blocks that way and turn. You turn and fire. Okay, so we call this polar graph paper that describes things in this way in terms of angles. Now, if you need a review of angles, I just made one, a review of the unit circle. Please watch that. It's a very short video where I talk about a reminder of these things. Then I have a longer video if you need even more details. But really, you can get away with a large part of what we're doing by just knowing those angles. Those are really important in polar coordinates because that's what it means to have an intercept. So it's not like x is 0 or y is 0. In polar coordinates, the intercepts are these angles. So you need to know them. And we actually can be looking this way or this way on the x-axis. So there's multiple angles that describe the x-axis. Okay, then you should know the ones in between. This really we'll need all of these, but you can just do it by splitting in half. So that's pi over 4. This is 3 pi over, and these are the conventions. The convention is to call this 0. Why? Because we all agree that that's the convention. Just like in Cartesian, we have some agreed conventions. Okay. And then similar, you can break it up into sixths. So pi over 6, pi over 3, which is 2 pi over 6. So there you go. So the rest of them are pi over 6s. When you see polar graph paper, they actually break it up even further into 12ths. So this would be pi over 6, and this would be pi over 12. But usually pi over 12 is not a value we get into. Even though there are more trig values, it's just they start to involve lots of square roots. So we don't usually include those. So this actually would be 5 pi over 12. So for the most part, we're looking at these 3 in the middle. We're looking at these angles. Okay. That's like these, what we call radial lines. So when we're talking in terms of polar, what we say is we're going to rotate. We're going to count positive angles as counterclockwise like we normally do. And we're going to count negative angles as clockwise. So this is positive angles. This is negative. That's the rotation part. So imagine you're standing at the origin and you're facing the x-axis. You rotate and then you walk. We are going to allow positive and negative distances to walk, but that's going to be your distance from the origin. Okay, so there's a few little things to say about that. It's just a different way of thinking. but it's valuable for many important problems. Okay, so if somebody hands you this, it is weird how they write. I feel like it's very strange because we typically are thinking in terms of theta. We think r in terms of theta. So usually we read the second number off first. So I find the coordinate notation in polar coordinates kind of awkward. I think of them separate, but it is standard. So if somebody gives me an angle, I first go look in that direction. So I rotate until I'm looking in this direction. So here's where it's important we know this story. So I'm looking this way. That's theta equals 3 pi over 4. That's why you need to know your unit circle. And then we walk out 2. And just like with normal graph paper, you get to choose how you want to label things. Let's call this 1, this 2, and this 3. It's like a radar screen. So that would be right there is that point. You can get to that point in many other ways. So in class, I'll think about other ways you can get there besides rotating and walking straight out. You could actually rotate all the way around. You'd be quite a little bit dizzier and you'd be in the same place, meaning do the same r, but add 2 pi. That will also get you to the exact same place. So that introduces this weird thing that didn't happen in Cartesian coordinates where we have ambiguity. It's even worse because you could rotate to face the opposite direction and then moonwalk backwards. So that would be like if you did theta was 3 pi over 4 and subtracted, say, pi, which would give it negative pi over 4, and then had r be negative 2. All of these are the same things. So you're going to have some homework questions that get you to think about that. They are not that bad. Just a moment here, I'll grab them. So they just ask you to plot. I think this will be routine for you. You're not actually, there is a formula to plug into to convert, but in terms of knowing the picture, you'll go to the angle, you'll walk out. Okay. So that's the idea. Maybe I'll leave it at that, and then separately I'll make a video on this idea of how do we convert.